So I'm kind of an idiot. I was building this workbench the other week, and I thought I had this stuff all put away, but evidently I did not. As you can see, I got sawdust all over everything, so we're gonna have to do a thorough cleaning of these heads. Oof. Oh. Make sure when you're working on Japanese products, use Japanese industrial standard screwdrivers. I have the Vessel ones, but you can get them from Annex or Sunfrag. The other thing is when things are tight, a handy dandy impact screwdriver is your best friend. Let's see if I can get that angle a little better. One of these guys. Once again, this one's from Vessel, but you can get them from Annex or Kokan or anybody. Got some extra bits. And make sure, again, when you're using the impact screwdriver, use a Japanese industrial standard bit. Otherwise, you're just going to round them out. Make sure. There we go. I just needed to support it a little bit better. Best tool. Well, not the best tool. One of the best tools ever. And if you do use a Phillips, because you don't happen to have a Japanese industrial standard, and you start rounding it out, grab some valve grinding compound, put it on the tip of your screwdriver, something with a little bit of grit in it, and then that actually works wonders to help extract them when they're starting to strip out. Alright, so I don't know if you can see that, but there's a little, it almost looks like a little pebble sitting right on top of the valve. There's a bunch more I blasted out with carb clean. There's a few more in there too. But I really don't want those dropping into the engine, scratching it up. So I think we're gonna pull this head apart a little. So we're popping these valves off just to clean them up. I didn't like that schmoo that was on there. As long as we got it apart. If you've never done this before, it's not too bad. Just get a valve spring compressor tool. So you pull your buckets off first. Make sure you remember which one's which. You have little shims under there to set your valve height, whatever gap between the cam lobe. And then once you have those off, you just grab a valve spring compressor tool. Get this at the old freight. And you just get it down to the point where you can get these keepers out. And you can push your valve right out of there. They're actually in pretty good shape. Not a huge groove on there. On motorbikes and such, especially titanium valves, once they start to go, there's no catching up to them. You're going to be adjusting your valves pretty much non-stop, so it's best to just throw some new valves in there. Time for reinstallation of the valves. We got the one exhaust valve in. We'll keep the camera rolling for the second one. Slide that guy right through the valve guide. Make sure it's seated nicely. Grab your spring assembly. Pop that guy right over the top of the valve stem. And grab your keepers. Just gonna drop it in there. Grab your fancy Harbor Freight picks. There. Set it right in position. I probably could have aligned the spring compressor tool a little better so I could get better access. Really, electromagnet would probably do this pretty well. Set it in there and just turn the magnet off. I don't know if that's a thing or not. Try to keep an equal gap on those. I don't know if it's super critical, but helps give you the warm fuzzies. Once those are in position, you can just slowly back this guy off. They're tapered, so they should just settle home. There. So one thing I wanted to touch on while I had these springs apart, not just applicable to valve springs, but you'll see it on suspension as well as progressive spring rate springs. A lot of guys have this misconception that this whole spring will, somehow this part will compress softly before this part compresses stiffly, but it's one spring, so the only way for that to essentially be effective is for this to mechanically bind such that it leaves the thicker or the more spaced out coils to give it the compressive force. So it is still progressive, but the way that it's progressive isn't just by these compressing lightly and then this one actuating, which in theory is sort of how it works, but these have to mechanically bind with one another before this part would technically be a higher spring rate. Slipping this koozie on is like trying to squeeze a piston inside of a cylinder. She is tight. Apparently this cutting mat really doesn't like carb clean. I was going to talk about something. Can't remember what. Spark plugs. So, I went and got some new plugs while I was in there. And figured I'd talk about hot type versus cold type spark plugs. So a lot of people think they'll put a hotter spark plug in there and make more power, but that's not the case. The temperature, the number here is what defines the temp of the spark plug, and all that's doing is defining how well it's going to burn off the carbon or what temperature range. It needs to burn off the carbon at the same temperature range, but how easily it'll get there. And so a hotter spark plug just means that if you're running at lower RPM or bogging around, it'll allow the spark plug to get hot enough to self-clean and burn that carbon off, versus a cooler spark plug or a cold type spark plug. In theory, you can run higher RPMs and make more power without causing detonation. So you don't want to just throw a hotter spark plug in and think that it's going to magically make more power. You got to be careful with it. Obviously, if you're following a lot of plugs and it's really dark black carbon buildup, then maybe you want to consider a hotter spark plug. But generally, whatever the factory calls out, factory recommended is perfect. Time to throw on the heads. So we have our F timing mark lined up, and currently the front cylinder is at TDC. And this guy should be, I don't know how far offset they are, but some arbitrary other position, and then we'll rotate it 360 to do the back cylinder. So interestingly, these cylinders, or these heads rather, come from the same casting. The only difference is, so you can see here, this is where your timing chain tensioner sits. These are both oriented the same way, and this one doesn't get machined out, but it has the same casting mark. They just machine out the backside, which is mirrored on this one. I was going back and forth about buying new head studs for it, but I don't believe these are torque to yield. So I'm thinking we should be all right. It's a pretty low torque value on them, comparatively speaking. I think this is as far as we're gonna get tonight. Tomorrow we'll, I gotta find the torque spec on these head studs. We'll mount this head, get the other head mounted up, get the engine itself all buttoned up. Time to torque these heads down. I'm not much of a torque guy, usually go by feel. But head studs are a little bit more critical. Get an accurate reading. You want to make sure you use some lubrication. This stuff has infinite stretch, I swear. It's insane. Look at that. So I was looking through the manual and it didn't say anything about replacing the head studs. And I'll pull up the torque value in a minute, but it seems to be a relatively low torque value such that, granted the shank of the fastener is thinner than the head, so you can't use traditional yield values for the size of the bolt and the grade of the bolt, but I think we're well within, well, at least well below the yield value for this hardware. When it comes to torque, it's not really a great way for measuring. I mean, it's a convenient way for a shop because you can't really measure strain, but really what you care about on fasteners is how much stretch you're getting out of the bolt. You know, torque is completely unrelated. Well, we've made it related, but some interesting things to note. So each time you remove these and reinstall them, you're essentially smoothing out the thread surfaces and the washer, the fang surfaces of the hardware. And so in theory, each time you torque it, you're imparting more strain on the fastener, so you'll get more clamp. And it's not necessarily what you want, and that's kind of why torque is a bad way to go about it, but it's good enough. And then, you know, of course, for head studs where your strain is critical and torque is the method by which you're trying to achieve that strain, it's good to use lubricant such that the friction doesn't, you know, the friction will give you a torque value far before the appropriate strain is achieved. So you want to reduce the friction so that you can get a closer to accurate way of calculating your stretch in the bolt. All right, so we do 18 foot-pounds and 30.5 foot-pounds. Got the trusty old Harbor Freight torque wrench. You can calibrate these, just measure X distance and hang a weight from it and see if you get your click. Or rather, incrementally get up to that weight to see if you have a click premature, and then incrementally add after the fact to see how close you are. And then I think maybe this guy backs out or something. You can adjust the preload on the spring to calibrate the wrench. So it is a cheap wrench, but you can still calibrate it to be within spec. We're not going to go to 18 straight away. Get everything clamped up first. All right, now we'll step it up to 30.5. Realistically, we're probably plus or minus a couple foot-pounds here. Perfect. Just tighten them up snug. I think the Machinery's Handbook calls it out. Elbow torque is in by feel, is within 30% of strain, which is what you care about. A torque wrench will get you around 20 to 25%. And then obviously using strain gauges or torque to strain fasteners with a little indicator on the head are sub 10%. But it's interesting that the delta between using a torque wrench and going by feel is, 10%. Relative accuracy, I guess, would be whatever. If you can do it 30%, a torque wrench can do it 20, then it's 30% more accurate, but perfect. Perfect. Hit these with some carb clean to get all that 30-year-old dirt off of there. So this bike, I want to say, has around 35 to 40,000 miles of absolute abuse. And everything is remarkably healthy. Like even these buckets, normally you'd see some sort of wear pattern from the cam lobes pushing on them over time. There is nothing. These cams are healthy, no pitting. The journals are all looking really good. Quite remarkable for what this bike has seen. Timing mark is still lined up. Perfect. Keep that tight. Throw a little extra sauce on there. Click. All right, that one's good. Then for the other cam, intake cam. All right, so this is going to have a 3. That is going to be 16 pins from the 2. I assume these should roughly be in line with the head. If you're cheap like me, and don't like buying new gaskets, sometimes a little trick you can do is just lightly dab some grease on the fang surfaces. It should help those gaskets pop off. Don't do it in critical areas, but on something like a cam chain tensioner that I'll probably pull out again in the future. Save a couple bucks. That's a bit too much. It also has the added benefit of holding your gasket in place. Is this thing polka yoked? No. So a pokey yoke is when the engineers are designing this, if it has a specific orientation, they'll offset that hole so it's not a straight 180 across. That way your parts can only be installed one way. Helps for manufacturing to prevent issues from popping up on things that need to be oriented specifically. So this is a little bit tricky because I don't have the holder tool. That's why I like the push button release. One hand, get your tool off. Click. Click. Mint. That seems kind of loose. We'll give it a few rotations and see if that can tighten up at all. All right. Do the cover, which is going to be pretty boring, so I'll leave that out, and we'll do the other cylinder, which is just going to be the exact same as this. I guess we can double check that our timing is correct. So we have our 1F parallel with the head. Timing mark is inlined with the F. These are aligned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is on the 3. Then you can double check and make sure both of your cam lobes facing away. The cylinder's at top dead. Rotate 360 and do the back one. So this might be sort of an interesting process. I want to see if this is going to get tight. We got to rotate the engine 360 degrees to bring this cylinder to top dead. So let's see if any weird noises pop up. What was that? So this would be the forward one. Cam chain tensioner finally seems to have settled into place. So I'll probably just edit the previous part out, but I was under the impression that the F timing mark was for the front cylinder and the R timing mark was for the rear cylinder. But as it turns out, use the F timing mark for both cylinders. I don't know what the R is for. Maybe checking valve clearance so that neither of them have any pressure on them. So I'm going to bring it back to F where both of these lobes are pointing out and timed, and then I'll rotate it 360. Alright, so there's our F. Those are out. Alright, so here's where we're going to go 360. So as I'm putting these washers on these studs, a question often gets brought up about washer orientation. So generally they stamp these out, and so on this face you can see the edges have a little bit of a radius to them versus this side's a little bit flatter. In theory, there is no washer orientation. Otherwise that would be defined either in the manual or even like NAS or mil-spec or ANSPEC hardware. That would be defined in the mil-spec document. And I got some mil-spec washers in here somewhere. There's one. So you can see the same principle applies, but really there's no burr on this face, so it shouldn't matter. It's more of a case-by-case basis. If you're fastening to, a painted surface, perhaps you'd want the beveled edge facing down so that you don't mar up the surface and you mar up the fastener, because you can replace fasteners. And then also if you're fastening, if they're cheap washers and they do have a burr and you're fastening to sheet metal, say, that burr could eat away at the sheet metal such that you'd want the sharper edge, the radius edge facing the material that you're fastening, and then the sharper edge facing the bolt head. But it just feels better to do it the other way, where the radius edge is facing the bolt head. I don't think it really matters, otherwise it would be defined somewhere. But it's not, more than just mechanics doing it as hearsay of what they've learned. What would be hilarious is if I dropped one of these screws into the engine. I had to get it on camera if I did. Nope, we're good. What a miracle. Alright, so we have our heads assembled. Spun the engine over a few times, we didn't see any binding. Quadruple checked the timing. Everything looks good. These Sparkies, they still have some life left in them. So we'll add them to the spark plug graveyard, or they'll never ever get used. Make sure you have these seals, O-rings, whatever they are, installed on your head covers. When I was in high school, all the streets were ATV trails. And so before you had your license, you just buy a quad and use that for your transportation. And I had an old DVX 400 Articat, which was just the Suzuki Z400. Kawasaki also had one. I think that was the KFX 400K. Yeah, I think it was the KFX 400. Anyway, they were all the Suzuki 400. And it had a Can-N on it when I bought it, paper filter, which doesn't filter for shit. So my intake valves were out. It was losing compression, it wouldn't really start. So I had to do a valve job on it. And when I was putting the head back together, I forgot to put those little seals underneath these cap screws. And broke the cam caps. This guy that it threads into cracked apart, so we had to weld it back together. So I got the new jet in, put the carbs back together, and one thing I wanted to touch on was the throttle position sensor. I had a mark on here, but it appears to have wiped off, which is fine, because I wanted to double check it anyway. So these two slots in here allow this to rotate so that you can set your voltage. A key component to that is that you want to make sure that there's no preload on the butterflies. They want to be in a completely relaxed state, and so you're going to, coupled with disconnecting the throttle cables, you're also going to want to turn your idle screw all the way out until you get a gap there so that you have absolutely no load on there, and then you can just follow your manual, back probe into the connector and set your TPS voltage. And you can tweak it a little bit depending on how the bike is running. So, all right, so the idea here is to pick the frame up and sit it on the engine. No idea how this is going to work. If I was smart, I'd have this all off, but I'm not smart. So we're just going to see what happens. Okay, over there. This is gonna require a little bit more attention. So we got this frame bolt here, kind of standard on the Japanese road bikes. She was jammed up, so I took the grinder. I've been using this socket for the frame bolts. I should probably just get the right one and I wouldn't have to deal with this, but locked right up. Grabbed her with the bare hands, the old bear mitts here. Look at that. So I've been threading it on this side and backing it out to clean those threads. Just like that, brand new threads. Might see if I have a thread chaser that's this big. I almost forgot to share. Got the engine mounted. Not entirely, I just got 4 bolts loosely in there. Took a lot of wrestling around to make sure that I could get everything aligned without binding anything up. Pretty important, especially on aluminum. You can get fatigue failures a lot easier on aluminum than steel. But we got her. So I didn't like trying to chisel this guy into the frame. So I just took a 9/16 and the old angle grinder, put 4 prongs in it. Now we got a custom socket. 9/16 because you don't want to sacrifice a metric socket. Alright, so we have all the frame mounting hardware installed. And I want to stress the importance of making sure that you don't just send bolts home to try and make holes align. Make sure that the frame is floating freely on the engine as best you can. Make sure everything's perfectly aligned so you don't have any binding. Another thing, a little pro tip, amateur tip, is so I wasn't sure if on the back side of these big bolts in here, if there were supposed to be washers that rest against the frame. So I've been referencing the sort of the parts diagrams quite a bit I do this all the time, but through the process just to make sure that I'm not missing any components and make sure that I have stuff aligned correctly. So just a little pro tip, amateur tip. We have progress. Wheels are on temporarily because I gotta replace some wheel bearings, but she's looking pretty good. Another little tip for you guys. Can't afford the fancy either magnetic sockets or nut grips. Just take a little piece of paper towel, press your bolt in, and that'll do the trick. This is the last of those East Coast beers, so I'm gonna save that one and switch back to the norm. I haven't been filming the progress much because it's pretty boring. Just putting in nuts and bolts, connecting harnesses, and putting it back together. Alright, so I'm pretty sure this little guy was a son of a bitch last time I took it apart. And I'm pretty sure there's a bunch of ball bearings in there that are all gonna fall out. Yep, there they are. Yeah, looks like I'm missing about 3/4 of them. So the key with these air boxes, you want to throw on the front side first, make it flush. I'm trying to turn my head, but this goddamn camera is falling off my head. Ugh. I'm in the wrong spot. So we got the front one on there. Seat it nice and well. I don't know if you can see what I'm doing. I can't even see what I'm doing. Alright, pretend that's tight. I'll tighten it once this fucking camera's off my head. So get the front one all cinched down. Then you take this rear guy here. And then you squish him down. Give her a little pry. make sure she's good and over the curvature there. And cinch her up. So I don't think I videotaped this part, but remember all the carbs were full of what appeared to be rust from this known to be rusted gas tank. Well, I filled it with a shit ton of vinegar. I know you can use Evaporust or citric acid or any other number of acids to eat away at the rust, but we're gonna give this a shot. Let her sit overnight. It's actually doing a pretty good job already. You can see on the neck. Throwing some new wheel bearings in it. Been doing a lot of work off camera. That's kind of boring. But I figured I'd show this part. Got the fancy Pittsburgh from Harbor Freight bearing puller. So we're just going to heat up the aluminum on the outside, and these bearings will pop right out of here. Oh yeah, plenty. And the other thing is, once you start trying to remove the bearings, you pretty much have to, since these are ball bearings. As soon as you put a radial load or an axial load on that inner race, you're gonna put a little peen in there, and the bearing's gonna be junk anyway. Got our new bearings in. New seal for this guy. These are definitely old stock that have been sitting on a shelf for quite some time. So, better not fuck it up, because we're probably not going to get too many more of those. All I'm really going to do is heat this guy back up, set this in here, and then I have this old bearing race from the triple clamps of CBR, I believe. It's just the right size. I don't have a socket quite big enough to kind of lightly tap that in there, so I'll either try this or else I'll take a brass punch and then just try to walk it in there. Alright, so we're pretty well heated up. My temperature gun's dead. I think you'd want it around 150 to 200 Fahrenheit. Alright, here I switched up tone there, that's how we know we're seated. You can see it up against the flange there. Perfect. We're gonna repeat that, it's gonna be pretty boring. 4 more to go, we'll keep that off the video. One thing to note when doing wheel bearings, so on the SV, the right side wheel bearing needs to go in first, and the left-hand wheel bearing will sort of float in here, and you can kind of see that. Oh, another thing, make sure you don't forget your spacer, but I still to hold that. You can kind of see the old marks. The bearing isn't totally seated against that face there, and with the other bearing fully seated, this sits a little proud of that lip. And that is intended, you know, the right hand wheel bearing is what drives the position. So make sure you check your owner's manual for which bearing needs to be installed first. For this one, we're going to do something a little different. We're going to try and press it in there. This is the floating side. I don't have a bearing press, so we're going to get kind of thrifty with it. I should cut this down to size, but I'm not going to. Alright, so we got this jumbo washer that's pushing against the sort of the hub of the wheel. We got our spacer in there. Snug that guy up. I want to make sure this guy is perfectly square. This inner washer just matches that outer race. It's super duper critical you're not putting a bunch of load on the inner race. I just wanted to make sure it was snug. I kind of want to do that by hand. Alright, so that's flush. This guy's pushing there. Nothing can go wrong, right? Oh, look at that. It's actually working pretty slick. So the key is to just be able to tell when the inner race interfaces with the spacer in there. Because you don't want any axial load on a ball bearing. Right there, just contacted. So I'm trying to wiggle the spacer back and forth, make sure there's no play in there. That noise is from me lifting it radially, but I think axially it feels pretty good. So I had mentioned I was going to adjust my TPS voltage because I had taken that off of the carb. Probably a good thing to check right now anyway. So this bike is a little bit different from what I'm used to. The way that you check it is that you check the throttle completely closed and you're checking for resistance in kiloohms, and then you hold the throttle wide open and it's a ratio for the resistance, as opposed to back probing and checking your voltage, your actual voltage. So I expect this one per the manual to be somewhere, so this is fully closed, to be somewhere around 5 ohms. And we're at kiloohms, so 5.018 kiloohms. And then multiply that by 0.78 gives us 3.9 ohms. So now we're going to switch to throttle wide open. So we're going to move this guy to this position. So right now we're getting 0.7. And now we're at, no, I didn't do my math yet. So we're at 4.06, call it 4.06 at wide open. What am I doing? Oh, right there, 3.914. So I need to adjust it. So we'll crack these guys loose. And so what your TPS is doing on a carbureted bike, sort of the best analogy for it is a GPS. So this is for your ignition timing. And so it's sort of saying, here's how much throttle we're asking for. And then obviously your computer knows what your RPM is at. And so depending on what load, if you're at a low RPM with wide open throttle, it's going to prevent detonation via timing. And so it's predicting the future of where does this bike want to be, like what's the destination. And so it's using your throttle position sensor to sort of communicate that to your ignition timing. 4.06 and I want 3.9. So counterclockwise is kind of where I want it to be. I gotta loosen those up a little bit more. Look at that, 3.9. Problem is, as soon as I tighten this, it's gonna go fucking all out of whack. And I couldn't tell you what an appropriate tolerance is on this. Wow. Dead nuts. What are the chances? I want to verify, double check the close position. 5.018, so we're still pretty much dead on. So that's how you set throttle position sensor voltage, evidently on a bike like this. Pretty easy. Going through, trying to figure out what left I have to complete this job. And I think to make it run, I pretty much just have to throw on the gas tank and the battery. And then, you know, other minor things like hooking up the brakes and doing some cable routing and such. But to get the old mill turning, I think bolt the radiator up, make sure it's full of coolant, oil, put the gas tank on, the battery on, and she should be ready to rip. Lenny's all giddy to go for a motorcycle ride. We got her chain and sprockets on, filled her up with oil coolant. We're gonna throw the battery in it in the moment of truth. See if she... We're gonna reupholster that, and we'll probably repaint the tank, but we're gonna see if she'll pop off for us. Got ourselves a new battery. All right. Oh boy, what am I forgetting? Hopefully nothing. All right, put the key. Okay, we have power. All right, runs good. We live in an apartment complex that hates noise, so I don't want to get booted out quite yet. I'll let her open up on the road. But that's a good sign. That thing fired right up. And it's running on premix, because that's all I had laying around the garage. All right, I gotta admit, that wasn't the first firing of it. I did pop it off about a week and a half ago, and it started, but it was running pretty lean. But I think that's because I didn't have the throttle position sensor adjusted quite right. But right there, it seemed to be running pretty well. So I think she's going to be fully operational. We're going to do some more cosmetic stuff. Get the seats revinyled, figure out how to do that. I kind of want to bondo the tank and repaint that, as well as the, I don't know, the front fender and the rear shroud area. Onesie twosie things just to make it look good, but otherwise I think it's going to be a fully operational motorcycle for the summer. All right, we'll take it out for a little ride. Let you see how she runs. that victory at part now. I just threw it on here so the cops don't have as much of a reason to pull me over. They already have enough reason. It's pretty well useless. Normally I'd let a brand new engine, not brand new engine, at least new rings warm up a little bit more before I take off, but that apartment really hates the noise, and I'm not trying to get booted, so so I had to get out of there. Radiator's starting to warm up. Pop action. Might have to try picking up the parts a little bit. Seeing what's going on with the jetting. Been to this bar yet, so we'll pop in and see what the clientele is like. So that's the old girl, pride and joy. Been through everything with her. I'll probably conclude this video, do some other stuff, but maybe I'll make a video of doing the seats in the tank. It won't be nearly as entertaining. I don't even know if this one's going to be entertaining. But she runs good. And if you're wondering why it's so loud, it's because it's got holes in the exhaust. Shoots flames out of both of those. It's pretty sick. And I'll never replace it. It's part of her identity.